In this demo, we're going to have a look at a simple image ribbon that we can use within our game as an example to provide a scrolling background or a moving background. In the associated lecture that goes along with this demo, we look at or introduce more fancy forms of image ribbon, where we may have a number of them that move at different speeds, and we do this to produce or to give the appearance of a parallax effect in terms of depth to an environment. But this demo here, really looking at the most simple case, which is going to be a single continuous ribbon that we're going to use for displaying a background within our game. But it does give you the foundation on top of which you can then extend out to get any of the more sophisticated forms of ribbon. So we'll show you first of all exactly what we're looking at here in terms of what it works, then we'll go through the code. There's a fair amount of code in this one just in terms of the environment that gets to be set up. But the actual ribbon bits are actually reasonably small, but we do want to go through the whole setup just to see how things are fitted together, or how things fit together. So this is part of the demo collection that was sent out. It's within our graphics, and it's ribbon test fragment. So it is actually a fairly large file, similar with the other demos. Everything's been stuck into one file just for reasons of simplicity. If we run that, so it'll be image ribbon test, and we can see the effect here. So what we will be creating within this is a long thin world, and inside that long thin world we're going to have a number of fish which are just put at random locations. So we're going to create an array of fish and give them a random y coordinate within the world and regular x spacing as we go through the world. And we will then have a viewport that will move through that world, and as it moves through that world it will make the fish become visible all within the viewport. So far so good. The image ribbon, we're going to use that to provide then a bit of background decoration. So other than having this layer with 100 fish and a viewport that we move through, we're in addition to that going to have a ribbon that we will be drawing initially for our background, and we'll do it in a way so that whenever the viewport moves, our image ribbon, the bits of the image ribbon that are displayed, also move. And linking the two things together then gives us the appearance that this particular layer, the game layer with the 100 fish, have this fixed background that we are also getting to see as the viewport moves through the level. So we'll have a look at all of this in terms of the code. Now, before we get into it, we might as well do a little bit of setup in terms of how it's going to be structured, because it is a little bit more involved in some of the other demos. So at the top here, we have notionally our game world. So we're imagining it as a long, thin space. And we will position our fish at random within that game world. So when we start it up, we're just going to position the fish wherever it is we want the fish to be. But that's notionally where they live within the world. We're going to have a viewport, and initially the viewport will start over on the left-hand side of the world, and as we update it, we'll move the viewport through the world, and it's going to enable us then to get to see whatever fish are within that particular viewport. Now, the game world, if you like, defined as this, it just contains the fish. It doesn't contain the background per se. So the background is a visual effect that we put on. And we want to do it effectively almost as if that we had an image here. These are seamless images, so if I were to combine them together, you don't see the joint between them. But one image there, and notionally, for example, if we had an image here at this particular side. So roughly that's the way we want the background to appear, as if we have it sort of continually pasted through our background. Now, to do that, we will effectively draw it out as if that is the case. So at the start, whenever we have our viewport over at the far left, we'll draw whatever part of the image ribbon is visible. Then as we go across and move through the environment, we'll eventually get into a bit where we are drawing part of the image, but the image that we're drawing now is left a blank bit at the edge of the viewport. And in that case, we're going to have to then draw a second copy, or a bit of the next copy, to give the appearance then that, okay, it is actually continuous, we're drawing the things together. And our viewport then, if we carry on moving it through, we'll go through a period where we are drawing out two images, or two copies of our background for completely filling it in. We'll then enter into another point where we only need to draw one copy out, because that one copy of the background completely fills the viewport. And as our viewport carries on, again we'll get into a position where we will have to draw out a second copy of it. And doing this then is going to be the mechanism where we're drawing it out once or twice to fill in the background, and we're tying how much the bits that we draw with movement in the viewport. So that's what we're going to try to accomplish overall with the code that we have available. So we'll have a look at this. At the highest level, we have our game world, which contains all of these things, and that includes the ribbon. We have our render view, which is the object that we're drawing these things to, and that contains our sort of crude approximation of a game loop. If we create it, create the fragment, we create the world, create the view, we create the render surface. But now, we'll have a look. We're going to have a box class that the game world will use. In creating this world and giving things a position, I'm assuming that positive y points up the way and positive x as normal points out to the right, which means then I'm not using rex. I'm going to use my own box class where positive y is up the way. But we'll look at that in a second. So we'll just initially have a look at the render view, because this is quite similar to some of the other demos. Whenever we're doing this here, we do a little bit just in terms of working out the size of it. We're creating a screen viewport. So this is the region we're drawing to, and we're making it sort of, depending on the size of the screen we're drawn to, a square viewport, on-screen viewport. The reason we make it a square on-screen viewport is that in the game world, I'm going to give it a square viewport into the actual world. So we're mapping it so it looks, has the right XY aspect ratios. On draw method, again, this is our approximation of a game loop. So this will be called the first time this view gets to be added to draw itself. When that happens, we'll update the world, and we'll then draw the world out. And we're giving it, okay, the canvas it can draw, and we're telling it, draw yourself to this region on the screen. And shouldn't really do this, but it's just our crude way of approximating the game loop. We'll go to sleep for a bit. We'll invalidate ourselves, and we'll recommence the whole update and draw process again. So that's a similar thing we've seen to some of the other ones. Box class, just have a look at that initially, get out of the way. So it is a box. We have an X and a Y. We're assuming that this is the center point of that box. So whenever we give fish a location, we'll say we want the center of the fish at this point, or whenever we say we have a viewport, the XY location will hold the center of the viewport. We'll then have a box width and height. And I am using proper width and height here. You can read the comment. In terms of actual algorithms, it's easier to use a half width and a half height because it seems you're dividing things by two. A few simple constructors where you can construct a default empty box or give it a specified size and position. So the game world then, this is the big bit. This is where all of the things happen. And we have quite a few things within this. The first thing we have over here is our approximation of our game objects. So we're simply going to have 100 boxes storing and displaying a particular fish bitmap. So that's the particular bitmap that we have there, and there's our image ribbon, the background that we had displayed. So that'll be the two images that we're using inside it. And that's all we're notionally going to have to represent our game objects. We're then going to have the two things that we have for our image ribbon, and ideally you would want to package these things up maybe in a nice ribbon class, but here they're just sort of spread across the game world. So we're going to have a bitmap for the actual ribbon itself, and I'm going to define a box for holding if you like, the bit of the ribbon, the background ribbon itself. Finally, I declare my layer viewport. So this is my window into my game world. and I want to draw any objects that fall within that particular window onto the screen. And again, I'm using a box, so positive y will point up the way. So that's all of our definitions. We've got our fish, we've got our ribbon, and we've got our viewport. Don't need anything else. For constructing this, so we call our setup world. Now, we are declaring the layer viewport. So conceptually, we are saying, and remember, this is not in terms of pixel values, this is in terms of layer values, or game world space. So this is independent of how big the bitmap is that we're drawing. It is independent of the screen resolution that we're drawing to. So we are imagining that our world is actually quite big, and our viewport is going to be a box that is 1,000 game units by 1,000 game units. And initially, we are positioning it at position 500, 500. So that, if we were to go back to this side here, and if it was, let's say, slightly square related, we would be having over here our initial viewport 1,000 wide, 1,000 high, and initially centered at position 500, 500. So it is over on the sort of edge of it. So the bottom left-hand coordinate corresponds to 0, 0 within our world. This bit here is a little bit of I did this here so that one of the assumptions in the algorithm works. So we are defining the ribbon so it's a bit bigger than the viewport. So in essence, what we're doing here is that we're taking the image that we have, and we're going to give it a certain size. We're going to say that the image is a certain size. And I don't want to have an image which is less than the size of the viewport. I want to have one that I know is a bit bigger than the viewport. And I do that because it means that I can potentially draw all of the image out once into the viewport. If I had it being a bit less, as in this case here, you can end up with situations where you have to do 3 draw requests, where there's a bit that needs to be drawn over on the left-hand side, then most of the image in the middle, and then a bit over in the right-hand side. And I want to avoid that situation where, in the worst case, I will have to do 2 draw requests, not 3. So making sure that it is wider than the viewport means that in the worst case, I only have to draw it out twice. That's why we put in that particular assumption. So I'm setting up my background ribbon, I'm giving it a box, and I'm making it slightly bigger than the width of my viewport itself, because I want the thing to not to have to do multiple draws, at most 2 draws. A bit here where we try to load in the fish and the ribbon. Fair enough, we've seen all that before. And a bit down at the bottom where we just randomly position the fish at regular X intervals, but at a random Y interval within our layer. And again, the random Y is from 0 up to 1,000. So we're assuming that for our world, it's 1,000 units high, and it's quite a few thousand units wide. That's the setup, so that will define our world. We have an update method, so we will be asked to update our world. Now, nothing much happens within our world other than the viewport moves. So we have our scroll speed. So every single time we do this, we will be updating, moving our X location for viewport by that scroll speed per update. So it's moving 10 game units per update. And we can speed the thing up, we can slow it down based on that. Now that's effectively it. That's the world defined, that's the world updated. The rest of the stuff then gets into the drawing. And as before, we're going to have a source and a screen rectangle. Because we are drawing to the screen, we need to be defining things using recs. The source rectangle, as before, will contain the region of the bitmap that I want to draw to the screen. And the screen rectangle is going to contain the region of the screen that I'm drawing to. I remember for all of these, positive Y points down the way. I will have my draw method, and I'm splitting it into 2 things. I'm going to have one method for drawing out the background ribbon. Now, the ordering here is important. So if we're drawing this out, we want to draw our background first of all, and then in front of that, we want to draw any of the fish. That's why we draw our background initially. That paints the screen, gives us our background. On top of that, we can go through and to draw our fish. Now, draw background ribbon is really one that's the salient one for us here, but just have a look at this one here for drawing the fish. We're going through the fish. we've got a method get source and screen rectangle. Now that's quite a useful method. It's quite a complicated method. I'll talk about that one later on. But basically it's a method where I can pass in a number of pieces of data. Let me just zoom down to it now to show you whereabouts it is. So down here, get source and screen rectangle. And it's one that you might want to adapt and use within your particular code. So in calling this method, I can pass in one box, which is the box of the game object that I'm interested in. And I can then pass in things about the width and the height of it in terms of that. I can pass in another box for the viewport. And this particular method will do a comparison to see if that entity is within that viewport. Now, if it isn't, and there's a chance that for 100 fish, most of them are not going to be within the viewport. So this will do a check, first of all, is it visible? If it isn't visible, the method will return a Boolean value of false. False means that you can't get the source and screen rectangle because it's not visible. False. If it is visible, then this method will return true. And true means that yes, it was possible to get a source and destination rectangle for it. And in that case, we've got our screen rectangle. The first rectangle here is for the screen viewport. So this is the viewport on the screen that we're drawing to. So we need that to work out where we do draw to. And the output from this, if it is visible, is that we will populate the source rectangle and we will populate the screen rectangle. And they will tell us where we actually want to draw the thing to on the screen. So it's quite a, we'll have a look at the method. It ties into the viewport talk, and basically this encapsulates some of the stuff from the viewport talk. But it's a useful method here. So if that is true, and that will only be true if it is visible, then we will have calculated through that method a source rectangle and a screen rectangle. All of the hard work will have been done. And we simply go to our canvas and we say we want to draw out the fish. Here's the bit of the fish we want to draw out. Here's the bit of the screen we want to draw to. And we're not saying anything about the paint, just the ordinary default paint. So that will draw out the fish that are visible on the screen. Anyway, so draw the background first of all, then draw out each of the fish that are visible. Now, this is the draw background ribbon. So this is really the thing we're interested in here for drawing out our ribbon to the screen. In essence, it is actually quite straightforward how it works. So if I have my viewport, let's say over here, I'm going to, notionally I know that the first ribbon will be here and the second one will be there and the third one will be there. So I'm going to be checking to see, okay, let me draw out the ribbon that notionally starts wherever the viewport starts. So the left-hand side of the viewport, I'm going to work out which image falls within the viewport. And I'm then going to draw that out. Now, either I will draw it out and there'll be a bit that's left, or I will draw it out and I will have completely filled in the viewport. It just depends whereabouts I calculate the background is starting from. In the situation where it completely fills the ribbon, I'm done. If there's a bit left, I will then do my second draw to provide and to fill that particular bit in. So that's what we do over here. The first bit is where I work out notionally which sort of image ribbon do I start off with. What's the first one? Whereabouts is it logically located? So we do that there by working out the image ribbon offset, which is simply the left-hand side of our viewport. So this is the center of the viewport, take away half of the width, that's the left-hand side. And we are dividing that, we're using modulus arithmetic here, the width of our background ribbon. Now again, just go back to this one here, that works out. So notionally our first ribbon is over here. And we take our viewport and we look at the left-hand side of the viewport. So I'm looking at the X location of this and I'm dividing it by the width of the background image. And any time up until here, the modulus arithmetic, because it's integer arithmetic, sorry, it'll automatically default to 0, which means that the first one we should be drawn is the index 0. As soon as I get to here, then in this particular case, I'm on to the next image, And if I divide the left-hand side now using integer arithmetic with the start of that one, I'll get a value of 1. So again, it's index 1. So a simple bit of integer arithmetic will give us notionally the first logical copy of the background image that we want to draw. And I then update my background ribbon to reflect that particular location. So I set the box location to be the first one that falls within the viewport. I then want to draw this out. Now, this is the exact same method as for get source and screen rectangle. I'm passing in our box, I'm passing in the width and height of the bitmap that I have associated with that box. I'm passing in the layer viewport and the screen viewport where I'm drawing to, and I'm getting out my source and destination rectangles. This is no if in this case, so I know it will return true because above I have calculated it so that it is definitely going to be visible. So there's no ifs, no buts about this, it definitely will be visible. I work that out and I then simply draw it to the screen through the canvas. So that draws out the first image in our ribbon. The second one then, I do have a check to make here because either I will have a bit to draw, which I don't have here, or I won't. So I don't have anything more to draw, or I do have something more to draw. So I want to calculate it for this particular bit. So we check then, background ribbon, the center plus half of the width. So this is the right-hand side of our background ribbon. This is where we have drawn to. If it is less than the right-hand side of the viewport, so if the right-hand side of the background, if it's less than the right-hand side of the viewport, it means we have not filled the thing in entirely. There's a bit remaining. In that case, we want to draw out our second image. So what do? We go to the box that represents our background image and we shift it one width to the side. This basically means that you're effectively drawn the next box, background, the next box along. So we shift it along. And we're doing exactly the same setup here. There's no ifs, no buts. It definitely will be visible because we worked out it is going to be visible. So we get the source and screen rectangle and we draw the thing out. And that's it. It is as simple as that one little method. It works because we've made a certain set of assumptions about the width of the background relative to the screen or the layer viewport, that it is always going to be visible within. It's not going to be smaller than the width of the layer viewport. Final thing, I'll mention this briefly, is this get source and screen rectangle. Effectively, this one method packages together the stuff we talked about within the viewport demo. So you might want to use this here or to adapt it, but by way of understanding it, go back and have a look at the viewport demo because it'll talk through this. But in essence, within this here, we have a check, an initial check to see is the thing visible? Is the particular entity bound, the bounding box that we have, does it fit within the viewport that we're using for our layer? So that's the first bit that we do. If that's true, then we know that it is. We're going to work out the source, X and Y location. This is relative to the bitmap. That's why we need to then use the other values that came in for the entity bitmap, width and height. So calculate the source X, source Y, source width, source height, scale it depending on the size of the bitmap. So at this point then, our source rectangle contains the region of the bitmap that we want to draw out to the screen. After that, we then work out, okay, what is the screen scaling between the layer that we use for our game and the pixel density that we have on the screen and the region that we're drawing to. We update our screen X, screen Y based on that scaling, and we calculate our screen rectangles. That's the region that we're drawing to on the screen. We're returning true if we've got as far down here because it means that it was visible and we've calculated our rectangles and we want to indicate that yes, the source and screen rect have been updated and can be used. If that big if at the top, if that wasn't true, in other words, it's not visible, then we return false down here, and it signifies that it's not visible. The source and the screen rectangle don't contain anything meaningful because the thing wasn't visible in the first location. So it all hangs together, where we are using a few sort of helper methods to help us get the thing out. But the basic notion of doing an image ribbon, given a few simplifying assumptions, is nice and straightforward. You may want to have a look at this. You may want to think about how you could extend beyond this. So you create, say, a class which enables you to use parallax effects, so that if the layer viewport moves, for example, by 10 units, that your ribbon would only move by, for example, 6 units or 4 units. And you can maybe vary this. And that then gives the appearance of the foreground objects moving more or further than the background objects move, and that we interpret then as a notion of distance, that the background is further away from the foreground because it's only changing more slowly. But overall, hopefully useful stuff.